In the previous video, we talked about advanced features using advanced features of Makefiles and Make as a build system. But in this video, we're going to talk about sort of meta build systems and what I mean by that. So let me explain this by saying the following. Right now in our project directory, we have a bunch of source files, C++ source files. And then we have also tried to write a sort of Makefile. If I tell you that if I ask you to basically take all these source files and also take the very same Makefile and then put it on a Linux machine and then try to use the make utility and the G++ commands, then most probably it's going to work, right? Your program is going to compile and you will be able to execute it because we do have access to make utility and also G++ commands right there, right? On a Linux machine. And also the fact that we are not using any crazy external libraries, we're just using the C++ standard libraries. We are not using very system dependent or let's say macOS dependent stuff in our C++ source code. But what if I told you to basically take everything and try it on a Windows machine? Then you would think for a second, you would say like, whoa, stop for a sec. I don't have access to G++ anymore on Windows machine. We are working with MSVC compilers. Then I also don't need a Makefile because the build system on a Windows machine is completely different, right? So you would realize that we have sort of a restriction or a limitation right there. Why? Because we are speaking the same universal language, C++ that is, but all of a sudden our build system is sort of hindering us to make us basically able to compile our project on different operating systems, whether it's going to be Mac operating system, Linux, or Windows. So here's the thought: wouldn't it be like really great if we had a tool that could help us, independent of the operating system that we are using, would help us to build and compile our project? Yes. Fortunately, there are let's say these families of tools that you can use, and one of the very powerful ones is of course CMake. CMake should be distinguished from Make itself because Make is a build utility, but CMake is not. CMake is actually a build recipe generator, you may call it. And all it does is that, what I mean by that, all it does is basically if you're working on a Mac operating system, if you have CMake, then CMake, you would give the instructions of the compilation of your project to CMake, and then CMake is going to give you one Makefile, which is specifically designed for that project, depending on the rules that you mention. If you're working on a Windows machine, on the other hand, CMake is going to hand you a solution or a project directory which is suitable for example, for Visual Studio to compile and run your project. So that's CMake in a nutshell. It's super powerful, it's very nice, and this video is just a scratch on the surface for CMake. I would encourage you to basically take a deeper look at CMake, but let's see how it works in our very simple project right now. So very similar to Makefiles, if you let's open this Makefile again. Is this Makefile human readable? It is. But is it easy to understand? Well, probably not, right? Because if you don't know really the logic behind Makefiles, then you basically wouldn't be able to tell what this thing does. But on the contrary, let's take a look at CMakefiles. The way that we do it, so we have Makefiles for Make utility, we have something called CMakeLists.txt for CMake. Of course, I'm going to open this file. Right now it's empty. We're going to fill it up. Mandatory stuff. You're gonna mention the minimum version. So we say CMake minimum version required. This is gonna be version, for example, I can put 3.0 right here. You're gonna name your project. I'm gonna name it as, for example, test. Now you can set some variables. You can say CMake, for example, CXX standard. And then I can put standard 11. This is very equivalent to this thing that we had in our Makefile. This is exactly like that. Now, let's also add some let's say, compile flag. I can say CMake CXX and then flags. And then I can say, for example, -w all to sort of activate all the warnings. What else can I do? I can also, let's say, set a directory, a binary directory, let's say. The variable for that is CMake, I think it was output. Let's see. Runtime output directory, this one. So this is going to be, for example, bin. And then if you want to compile a library, then you need to include directories first. You say include directories, as simple as that. And then you would say my directory is this one. And then you say add library. And then you would say my library is called Runge-Kutta, and it depends on include and Runge-Kutta.cpp. And then you can also add an executable just like that by saying my executable is a.out, if you remember, is the default with G++. And then you can say it depends on main.cpp. And then finally, you need to link these two together. So you can say target, link libraries, and finally you can say link a.out and Runge-Kutta. As simple as that. Few lines of instructions to CMake. This is the very basic CMake file that you can generate. Now compare this to the Makefile that we have written. This is much, much easier. Even if you don't know what CMake is or what CMake does, you can read it like as a plain English thing. You can say, okay, include directories. So we're going to include some stuff. Then we're going to make a library, it seems like. Then we're going to add an executable. And finally, we're going to link them together. So you understand the workflow of your system, right? So let's test this out and see whether it works. I save this. The way it works, you're going to make a build directory. Then you're going to go cd into that. Then you're going to say CMake. Right now it's empty, of course. And then you're going to say CMake and then double dot, which means the previous directory, right? If I hit the return key, take a look at this. It basically identifies your C compiler. It's Apple Clang. It identifies the CXX or C++ compiler. And it tries to basically give you a Makefile finally. And then you see that we have a bin directory right here. If I cd into that, it's empty. Right now, there's nothing there. But we have a Makefile. Isn't that like interesting? So let's take a look at this Makefile. Whoa, whoa, whoa. Take a look at this. It's 221 lines of sort of instructions. And we also have a very nice help right here. Just take a look at this. We have a help file for our Makefile. Compared to our Makefile right here, which is very simple, 25 lines of sort of instructions, let's take a look at this one. Now, if I say make, then it's going to build the project for me, right? And take a look at this. I have my lib-runge-kutta.a. It's an archive, so it's a static library. And if I go to my bin directory, you see a.out right there. Then you can test your program. And voila, you get your results, right? So by default, it's going to be a static library, but we can also make shared libraries. So all you need to do is to go back here, and here you can add the keyword shared, and you save this file. You go into your build directory, you say CMake, and then this thing. Then you're going to remove your lib-runge-kutta.a, and then you say make again. And it's going to build you. It also says here, it's a shared library, lib-runge-kutta dynamic library. So, but you already see that it's not .so anymore. Why? Because we're working with Mac operating system, and dynamic libraries are properly named as dylib or dynamic libraries under macOS operating system. So now if you go, for example, I can try to run it right here. You can test it, and still it works. And take a look at this. If I say make help, then you see, for example, we have access to, we have a make Runge-Kutta command. So this most probably is going to only update our library. Let's test this out. If I go back to my, for example, include directory and then Runge-Kutta.cpp, I can go down here. I can remove this hello, and then I come back to my build directory, and then I say make. If I say make, it's going to compile everything for me. But instead, I'm going to say make Runge-Kutta. Check this out. It says building the library, and this thing is updated. And now if I try to run my binary a.out, so I shouldn't see any hello right there. So this binary is the old binary that I had, right? What else can we do with that? We can say, for example, make help, and check this out. So we have a list of stuff that we can do. For example, let's take a look at this. We can have also pre-processed version of our main.cpp. Let's check this out. So if it's a main.i, if I do that, it says pre-processing CXX source file, and then it puts it in here, so I can go to CMake files, and then I can go to a.out directory in the main.cpp I, and there we go. This is our pre-processed C++ source code, main.cpp. You see that our code has expanded itself to 48,437 lines of code. And at the bottom of the file, we have our main function. You see that the preprocessed version, it doesn't have any comments anymore. So comments are going to get completely eradicated. And there we go. Here is our sort of Runge-Kutta header file. It's just copied and pasted right here. And all this stuff up here, all of these like thousands of lines are related to std vector we were using, and we were using iOS stream and stuff like that. So we can also have a version of sort of a pre-processed version of our Makefile. So that's basically CMake in a nutshell. So now you see the power behind CMake, that it basically makes your applications, makes your build system sort of cross-platform. Now you don't have any hindrance. Like if you're on a Windows machine, you can use basically more or less the same CMake file that we generated right here, this CMakeLists.txt. You can use this one, and then what CMake will do for you is instead of handing you this make file, it's going to give you solutions and sort of project directories for Visual Studio, for example. So as I said, this is just a scratch on the surface. I would encourage you to go deeper and learn more about CMake, but this is basically CMake in a nutshell, and a very simple CMake instructions for our simple C++ file. I hope you learned something from this video, and hope to see you in the next one.